During an International Space Station Earth View livestream on November 18, 2025, everything looked routine. The Earth drifts below the International Space Station, calm, blue, and familiar, streamed live to millions of viewers around the world. Then, without warning, something flashes across the frame. A bright object, sharp, fast, gone in seconds. Before anyone can rewind or take a closer look, the ISS livestream cuts out. The image turns blue. The feed is silent. Within hours, clips of that moment spread across YouTube, Reddit, and X, pulling in millions of views and igniting the same question again and again. Why did the signal drop at the exact moment the object appeared? NASA has acknowledged that ISS livestream interruptions happen regularly due to satellite handoffs and signal loss, a fact documented in public briefings. Still, the timing feels unsettling to many viewers. Because this wasn't the first time. Similar clips have been circulating online for about a decade, following the same pattern: a flash, a cut, and a mystery that refuses to disappear entirely. To understand why these moments feel so unsettling, you first have to understand what the ISS livestream actually is and what it was never meant to be. The Earth View feed runs around the clock, pulling images from several fixed cameras mounted on the outside of the International Space Station. These cameras aren't controlled by astronauts. They don't zoom in, track objects, or react to what's happening on screen. They simply point outward, capturing whatever drifts through their field of view as the station races around the planet at roughly 17,500 miles per hour. The signal from those cameras doesn't come straight down to Earth. Instead, it hops through NASA's Tracking and Data Relay Satellite System, a network of relay satellites positioned to keep contact with spacecraft in low Earth orbit. When the geometry is right, the connection is clean. When it isn't, the signal drops. That handoff happens constantly, quietly, and usually without anyone noticing. The livestream itself was created for a simple reason. It's there to educate, to inspire, and to give the public a real-time window into life in orbit. It was never designed to collect scientific evidence or monitor anomalies. In fact, NASA has repeatedly stated that all critical scientific data from the ISS is transmitted through separate secured channels. What you see on the livestream is closer to a public-facing camera feed than a research instrument. Here's the part that often gets overlooked. The ISS circles Earth roughly once every 90 minutes. During each orbit, there are predictable stretches when the station passes through areas where no relay satellite is positioned to carry the signal. Engineers refer to these moments simply as loss of signal. When that happens, the livestream doesn't fade out dramatically. It switches to a default blue or blank screen and waits until the connection returns. Most of the time, viewers barely notice, but when a bright object appears seconds before the feed cuts, the silence feels louder than the explanation. The interruption suddenly looks intentional, even when it isn't. Those gaps, brief and technical, create space for suspicion. In a world trained to expect constant connection, any sudden silence feels like something being taken away. And when that silence follows something unexpected on screen, it's easy to believe the mystery came first and the explanation came later. That pattern, more than the object itself, is where the doubts begin to grow. When viewers slow the footage down and replay it frame by frame, the mystery doesn't disappear. It intensifies. The bright object caught on the ISS livestream doesn't have a clean outline. It isn't a solid shape you can easily name. In one frame, it looks like a sharp point of light. In the next, it stretches, fades, or briefly flares before slipping out of view. What makes people uneasy isn't just that the object is there, it's how it appears to move. In the slowed footage, the light doesn't seem to follow a straight path. Instead, it looks like it curves, hesitates, or subtly changes direction. To many viewers, that motion feels deliberate. Comment sections quickly fill with familiar reactions. Some say the object is pacing the ISS. Others claim it's adjusting its trajectory, as if reacting to the station itself. But this sense of intent is exactly where perception begins to quietly reshape reality. The cameras mounted on the International Space Station are far simpler than many people assume. They do not zoom in. They do not track objects. They do not swivel to follow movement. Each camera is fixed in position, pointing outward into space, capturing whatever happens to cross its field of view as the station speeds along its orbit. And that speed matters. The ISS travels around Earth at roughly 17,500 miles per hour. Against that backdrop, even a small object drifting nearby can appear to behave in strange ways. When something passes close to a stationary camera while the station itself is moving at extreme velocity, its apparent motion can feel unnatural. Slight changes in angle, distance, or lighting can make a simple drift look like a sudden turn. Lighting plays a major role too. As the ISS moves in and out of sunlight, reflections can change instantly. A bright speck can flare when it catches the sun, then dim just as fast when the angle shifts. Combined with video compression from a public live stream, edges blur, motion stutters, and the object's path becomes harder to interpret. This is where the human brain fills in the rest. We are wired to search for patterns, especially when something unexpected appears and vanishes without explanation. When information is incomplete, the mind connects dots that may not actually exist. A random pass becomes a guided maneuver. A floating fragment becomes something aware. The footage itself doesn't tell a story, but the moment it creates does. And once viewers feel that something might be intentional, it becomes almost impossible not to see purpose where there may only be coincidence. That feeling is powerful, and it sets the stage for everything that follows. The suspicion doesn't peak when the object appears. It peaks when everything goes quiet. Seconds after the bright shape slips out of frame, the image disappears. The familiar view of Earth is replaced by a flat blue screen. No countdown, no explanation, just silence. For many viewers, that sudden absence feels more unsettling than the object itself ever did. Online, the reaction is immediate. The question isn't what was that object, it's why did the feed end right then? Comment sections fill with the same assumption. Someone must have intervened. Someone must have seen what was coming and shut it down before viewers could look closer. But what gives this moment its power isn't the cut itself. It's what doesn't follow. There is no alarm, no warning message, no indication that anything unusual is happening aboard the station. The ISS continues its orbit. Astronauts carry on with their routines, and when the signal returns, the live stream resumes as if nothing ever happened. That lack of reaction creates a vacuum, and human perception hates a vacuum. When a live stream ends during a quiet, uneventful moment, most people shrug and move on. But when it ends seconds after something unexpected appears, the silence feels loaded. The mind instinctively links the two events. Object, then blackout. Cause, then response. Even without evidence, the sequence feels meaningful. This is where coincidence begins to look intentional. Psychologically, silence is powerful. It invites interpretation. It encourages the brain to fill in missing information with intention and motive. A blank screen doesn't feel neutral. It feels like something was withheld, especially in a world where people expect constant access, constant explanation, and instant replay. The blue screen becomes more than a technical placeholder. It becomes a symbol. To some viewers, it looks like a door closing. To others, it feels like a conversation abruptly ended. The longer the screen stays blank, the more space there is for suspicion to grow. Social media amplifies that effect. Clips freeze the moment. They remove context. They loop the object, then the cut again and again. With each replay, the timing feels less accidental. the narrative tightens, even if the reality hasn't changed at all. This is why these moments linger, not because something extraordinary happened, but because the interruption happened at exactly the wrong time for the human mind to accept easily. The absence of information becomes more memorable than the information itself. Once people notice this pattern, every future interruption feels different. A routine loss of signal begins to look like a decision, and each quiet return of the live stream raises the same unspoken question. Not what we see, but what we don't get to see. That question, more than any object on screen, is what keeps these clips alive long after the feed comes back online. By the time this latest clip went viral, it was already part of a familiar archive. Videos with almost identical titles have been circulating online since at least 2014. Different years, different camera angles, different moments in orbit. Yet the sequence barely changes. A bright object drifts into view. Viewers notice it at the last second. Social media erupts. Then the ISS livestream cuts out, leaving behind a blue screen and a flood of speculation. Over time, this pattern has become a genre of its own. Researchers, space agencies, and independent analysts have gone back through dozens of these clips, comparing timestamps, orbital positions, and lighting conditions. According to summaries released by NASA and echoed by European and Japanese space partners, the majority of these sightings are not unidentified at all. More than 60% have been traced back to familiar causes after closer examination. Some turn out to be pieces of space debris, small fragments left behind from old satellites or rocket stages that have been tracked for years. When they pass close to the ISS and catch the sun at the right angle, they flare brightly, then vanish just as fast. Others are something even closer to home. Tiny ice crystals regularly form when water vapor or waste is released from the station's life support systems. In the vacuum of space, that moisture freezes almost instantly, creating reflective flakes that drift alongside the ISS. To a fixed camera, these fragments can appear to float, accelerate, or change direction as the station moves past them. Light itself adds another layer of confusion. Reflections from solar panels, antenna structures, or even the curvature of the Earth below can produce sudden flashes that look solid on screen but have no physical object attached to them at all. Yet despite all of this, one type of sighting continues to trip people up more than any other. It's the ones that look closest. The objects that appear large, bright, and just slightly out of focus. They don't behave like distant debris. They seem too near, too prominent, and because of that, they feel harder to dismiss. In reality, proximity is exactly what makes them deceptive. Objects very close to the camera exaggerate motion and brightness, especially when combined with extreme orbital speed and shifting sunlight. What looks massive and intentional may actually be small, fragile, and drifting just a few feet away. But once a viewer believes they're seeing something new, every explanation sounds like damage control. After more than a decade of near-identical clips, the mystery isn't why these videos exist. It's why the same visual tricks keep working. Because even when most cases are explained, there's always that remaining fraction. The ones that don't immediately fit. The ones that look just strange enough to keep the story alive. And among all the debris, ice, and reflections, one category continues to blur the line between misunderstanding and belief more than any other. Among all the explanations offered over the years, none feels as counterintuitive as ice. The International Space Station constantly releases small amounts of water vapor and other gases as part of its life support and thermal control systems. This isn't waste in the everyday sense. It's a necessary process that keeps the station stable and the crew alive. But once that moisture leaves the station, it enters a place where the rules are very different. In the vacuum of space, water doesn't behave the way we expect. There is no air to carry it away, no warmth to keep it liquid. Instead, it freezes almost instantly. What forms are tiny ice crystals, sometimes no larger than grains of sand, drifting away from the station's exterior. On their own, these crystals are invisible, but when sunlight hits them at the right angle, everything changes. Ice is highly reflective. As the ISS moves from shadow into sunlight, those crystals can suddenly flare with intense brightness. To a camera fixed in place, a single crystal can light up like a spotlight, appearing far larger than it really is. As it rotates slowly, the reflected light flickers and pulses, creating the illusion of shape and structure where none exists. This is where motion becomes deceptive. The ISS doesn't stand still. It races around Earth at roughly 17,500 miles per hour. As the station adjusts its orientation to maintain power, control temperature, or align antennas, the angle between the camera, the sun, and nearby objects constantly shifts. A drifting ice crystal caught in that changing geometry can appear to veer, accelerate, or even reverse direction on screen. To the human eye, it looks controlled, intentional, almost guided. In reality, nothing about the crystal is changing its course. The only thing changing is perspective. A slight rotation of the station alters the angle of reflection. The light bends differently. The bright spot slides across the frame. What feels like a maneuver is simply geometry playing tricks on perception. NASA has explained this effect repeatedly in public statements and educational materials, noting that ice crystals are one of the most common sources of misidentified objects in ISS footage. They are close to the camera, highly reflective, and unpredictable in appearance. That combination makes them especially convincing when viewed without context. What makes ice such a powerful illusion is how alive it looks. It doesn't streak by like distant debris. It lingers. It floats. It reacts to light in a way that feels responsive. And when it vanishes just as suddenly as it appeared, the moment sticks in memory. But once you understand the mechanics, the magic fades. The movement isn't guided. The brightness isn't energy. The behavior isn't intelligence. It's simply frozen water catching sunlight while the station moves beneath it. The problem is that our brains don't see geometry. They see motion, and motion, especially in silence, feels meaningful. That's why ice, more than debris or reflections, has quietly become the most convincing imposter in the long history of ISS UFO sightings. One detail often gets lost in these discussions, and it changes the scale of the story completely. The International Space Station does not belong to one country, and it is not watched by one set of eyes. It is a joint project, monitored around the clock by multiple space agencies with shared responsibility and shared data. Alongside NASA, the ISS is continuously tracked by Roscosmos, European Space Agency, JAXA, and Canadian Space Agency. Every one of them follows the station's position, orientation, and environment in real time. That level of oversight matters. The ISS's orbit is not secret. Its path around Earth is published, predictable, and constantly updated. Amateur astronomers track it from their backyards. Universities log its passes. Independent researchers monitor not just the station itself, but the growing cloud of debris that shares low Earth orbit with it. This information isn't locked behind government firewalls. Much of it is public by design. The same is true for space debris. Thousands of objects, from defunct satellites to fragments no larger than a bolt, are cataloged and tracked. One of the most widely referenced datasets comes from the US military's orbital tracking system, commonly known through its NORAD catalog. Analysts around the world use that data to predict conjunctions, close passes, and potential hazards. When researchers began comparing timestamps from viral ISS livestream clips with orbital data, a pattern emerged. In many cases, the bright objects seen on screen lined up with known debris trajectories. The timing matched. The relative motion made sense. What looked mysterious in isolation became predictable when placed against a larger map of what was already up there. This is where the idea of a coordinated cover-up begins to strain. For something significant to be hidden, It wouldn't just require silence from NASA. It would require every partner agency to stay quiet. It would require independent observers to miss the same event. It would require public tracking networks to somehow overlook an object bright enough to appear clearly on multiple ISS cameras. That level of control isn't just difficult, it's unrealistic. And yet the question doesn't disappear, because if the system is so transparent, so widely monitored, why do these moments still feel unresolved? Why does the appearance of a simple bright object still spark doubt? The answer may not lie in who is watching the ISS, but in how people interpret what they see when technology, speed, and distance collide. The station is surrounded by observers, but the experience of watching a live stream alone, without context, can make even the most ordinary event feel isolated and suspicious. That tension between global oversight and individual perception is where the real mystery begins to take shape. At this point, the question shifts from what was seen to something much larger. If there really were something extraordinary near the ISS, could it actually be hidden? NASA operates under strict legal and institutional rules. Any discovery with real scientific significance isn't optional to share. It must be documented, reviewed, and in most cases, released. That obligation exists precisely because space is not owned by a single nation, and neither is the ISS. The station is an international project by design. Its systems, experiments, and operations are shared across agencies in the United States, Russia, Europe, Japan, and Canada. Data moves through multiple ground stations, oversight teams, and partner institutions. For a single organization to quietly suppress a major finding, every other partner would have to agree to stay silent. Not for hours, not for days, but indefinitely. That kind of coordination sounds plausible in movies. In reality, it falls apart quickly. There's also a crucial misunderstanding at the center of many online theories. The ISS livestream is not a scientific feed. It isn't used for measurements, discovery, or analysis. It's a public-facing window, meant to show Earth from orbit and offer a sense of presence in space. The cameras are simple, the footage is compressed, and none of it is treated as primary data. All official research collected aboard the ISS travels through separate channels entirely. Sensors, instruments, and experiments record their findings independently of anything shown on YouTube or NASA TV. Those datasets are logged, archived, and shared with research teams around the world. If something unusual were detected, it wouldn't appear first as a blurry flash on a public livestream. This distinction matters. Cutting a livestream doesn't erase evidence, it doesn't stop data collection, and it doesn't prevent independent observers from noticing the same event. If something large, structured, or truly unknown were near the station, it would be visible across multiple systems, not just one camera feed watched by the public. That doesn't mean distrust is irrational. Space feels distant, the technology is complex, and when a signal drops at the worst possible moment, it's natural to wonder what wasn't shown. But the idea of a hidden truth hinges on the assumption that the livestream is where the truth would appear in the first place. It isn't. Which leads to a quieter, more uncomfortable conclusion. The mystery may not be about secrecy at all. It may be about how easily limited information, presented without context, can feel like a revelation. And when the explanation is technical instead of dramatic, it often feels less satisfying than the suspicion it replaces. When you step back and look at these moments as a whole, the story shifts, not towards something more sensational, but towards something more revealing. The strange flashes on ISS livestreams aren't evidence of a hidden truth waiting to be uncovered. They sit at the crossroads of complex technology, limited context, and the way our minds react when certainty suddenly disappears. The International Space Station is one of the most advanced machines ever built, yet its public-facing systems are remarkably simple. Fixed cameras, compressed video, signals that depend on perfect timing between satellites moving thousands of miles above Earth. When something unexpected enters the frame and the feed cuts seconds later, it feels personal, almost intentional. But those moments are shaped by physics and geometry, not secrecy. What gives them power isn't what they show, but what they interrupt. A calm view of Earth, a sudden flash, then silence. And in that silence, imagination rushes in. We fill the gaps with purpose and meaning because a technical explanation rarely feels as satisfying as the idea that something important was almost revealed. Space doesn't need alien visitors to feel unsettling. Distance alone can do that. Speed can do that. Systems that don't behave the way we expect them to on Earth can do that. A drifting ice crystal can feel alive. A reflection can look deliberate. A blue screen can feel like a door being slammed shut. None of this means curiosity is wrong. Questioning what we see is how understanding begins. But there's a fine line between curiosity and conclusion, between mystery and evidence, between asking questions and answering them too quickly. And that brings the story back to us. When you watch that moment, did it feel like something was taken away from you? Or did it simply expose how little context we often have when we look into space? Let us know what you think in the comments. And if stories like this change how you see the unknown, consider subscribing to MindGap for more moments where technology, mystery, and human perception collide.